Welcome to the lair of the Batty Boffin.
Hi there Batty fans, a little bit more on the subject of equations with the Batty Boffin. Now, earlier videos in this series we've looked at solving linear equations, 2 stages and 3 stages. Today we're going to be looking at some more 3-stage equations, but these ones are a bit harder. All the earlier ones have had kind of nice answers like 2 and 5. These ones are going to have some slightly more hairy numbers in them. Same technique, but more awkward numbers. So I hope you're okay on dealing with all the fractional bits and all the negative bits, and we'll see how we go. Shall I do a demo one here? Yes, I think I'll do a demo on this one, and then I'll let you loose on the blue one, and then we'll give you a couple more for you to do. So we're going to use this by doing the Cadbury's Cream method. We put little circles around things to remind you what order we do them in. Remembering that X is like the prize in the middle of a pass the parcel, and we're wrapping it up in some layers. We've got an add 4 layer, we've got a divide by 3 layer, and a multiply by 2 layer. And we're going to wrap the X up in those layers using our Cadbury's Cream egg thing to remind us which one. And then we're going to take the layers off from the outside, working with until we find out what X is. So doing that here, we've got the X. Now we've got a multiply and a divide. Those are both on the same level. Just a note here, if you're using BODMAS, BIDMAS, PEMDAS or something else like that, I'll just write it out down here. I'm going to use BODMAS, the other ones are all the same. Brackets or parentheses, if you're using PEMDAS, are what we do first. The O, which is for other stuff or order or exponential or indices, if you're using I's on there, come next. And a lot of people think that after we've done those two, then we do all the divides. And when we finish those, then we do all the multiplies. Okay, that's not actually true. If you've been told that, that's not wrong. That one is first. That one is second. These are third. And these are fourth. Okay, divides and multiplies go together, adds and subtracts go together. To be honest, a lot of the time it doesn't make a difference, but sometimes it actually does. So when you're doing these, all brackets first, then all powers and stuff like that next, and then divides and multiplies, which are at the same level, and then adds and subtracts, which are at the same level. So on our equation here, up here, we've got a times by 2 and we've got a divide by 3. Those are both at the same level. So for this one here, we're actually going to put, I'm going to put the ring around the multiply as being the closest in one, just because it makes it slightly easier. It doesn't actually matter on this one here. And then the divide by 3, and finally the add 4. So when I get rid of these, I'm going to get rid of them outside working in. So first of all, I'm going to get rid of that plus 4 by doing a take away 4, which gives me 2x over 3 is equal to 7 minus 4 is 3. Then I'm going to get rid of that 3 on the bottom. It's a good technique. If ever you've got anything that's got a fraction in it, good technique is multiply by whatever's on the bottom of the fraction, because fractions, quite frankly, are a bit of a pain in the nether regions. So let's try and get rid of them. So we're going to multiply by whatever's on the bottom of the fraction. In this case it's a 3. For more complex ones, you might not have a number there, you might have an expression like x minus 2. That's fine, just multiply by x minus 2, whatever's on the bottom. So this gives us 2x equals 9, a quick little divide by 2, and we get x equals, and I'm going to write that as 9 over 2. 9 over 2, the fraction. It's perfectly okay to leave things as fractions. They're actually easier to understand sometimes than some decimals. You could, of course, put 4.5, or you could put 4.5. Okay? When you get further on in maths, you'll find actually that the fractions are easier to understand. If you have something like 2 over 17, that's a bit easier to understand than whatever the decimal is for 2/17, which I frankly have no idea, and they're usually hideous. So don't be frightened of fractions. When you've got them like that for an answer, it's perfectly okay to leave your answer as a fraction. Okay, so there we got 9 over 2 as our answer. Could you have a go, please, at this one? It's going to have some similar, slightly awkward numbers in it, so I hope you're okay with your fractions. If you're not, there are Batty Boffin videos to help you. So pause the video, have a go with the blue one now. Right, let's have a go with that. First of all, we're going to put the little rings around it. We've got brackets on here, so that means that that addition is the closest in one. followed by the multiply, followed by the subtraction. So getting rid of the outer layers first, we're going to get rid of that subtract 4 by doing an add 4 on both sides, which gives us 5 lots of x plus 2 is equal to 7. Now we're going to get rid of that times by 5 by doing a divide by 5, which gives us x plus 2 is equal to, and I'm going to leave this as a fraction, 7 over 5. Okay, 7 over 5. You could call that 1.4 if you wanted, but I'm going to leave that as 7 over 5. And then I'm going to subtract the 2, which gives me x equals, now 7 over 5 take away 2. Actually, I'm going to write that as a fraction take away. So 7 over 5 take away, and 2 I'm going to write as 10 over 5. Yeah? Because 10/5 is 2. Okay, I'm just going to move that up a bit because that's kind of crunching in there a bit. 7/5 take away 10/5 is negative 3/5. Or you could write negative 0.6. Either one of those two is fine. Okay? Another way of doing this, by the way, would be to expand those brackets and simplify the left-hand side, at which point it would turn into something nicer. That is also a perfectly fine way of doing it. I'm using it this way because I'm illustrating the 3-stage method. Okay? But if you did it by multiplying out, totally fine. As long as you got the right answer, I don't mind. Okay, I'm going to wipe down the board and then we'll come back with a couple more for you to have a go at. See you in a minute. Right, here we come back with another one. Here we've got another 3-stage equation, and what we're actually going to do here is we're going to solve it 2 different ways. As I mentioned just before the break, we can either solve it by doing it as 3 layers, or we can multiply it out and simplify it. And I think we're going to do it both ways and see what happens there. So for starters, if you could pause the video and just solve that using its 3 layers as written there, you're going to get a yucky number as the answer. And let's have the answer as a fraction, I think, please. Okay, off you go with that. Right, here come the 3 layers. We've got a bracket, so that's the inner one. And then we've got this multiply out here, and then we've got, nearly hit my heading there, that divide there. Okay, so first of all, moving that 3, we're going to do a times by 3 on both sides, which gives us a 4 lots of x plus 3 is equal to 15. Dividing by 4, here's where the fractions come in. So we're going to have an x plus 3 is equal to 15 over 4. And I think I'm going to leave that as a top-heavy fraction. You could turn that into a mixed number if you wanted to. Actually, no, I will turn that into a mixed number because it makes it come out quite nicely. 15 quarters is 3 3/4. And that makes it quite nice. When we take away the 3 at the end, we get x equals 3/4. Okay? Now what we're going to do over here is we're going to have exactly the same problem. 4 lots of x plus 3, whole thing divided by 3 equals 5. What I'd like you to do here is to simplify the left-hand side as much as possible. Okay? And then solve it from there. Okay, so pause the video, have a go with that now. Right, let's look at simplifying this. First thing I'm going to do is multiply by whatever's on the bottom of the fraction. So we're going to get a 4 lots of x plus 3 equals 15. Okay, we can multiply this out now, that's much nicer. So we're going to get a 4x plus 12 equals 15. Right, we've now turned this into a 2-layer problem with a times by 4 and a 12 on there. That's much nicer. So we're going to do a take away 12, gives us 4x equals 3, and a quick little divide by 4 gives us x equals 3/4. Doesn't matter which way you do it. That one we did as a 3-layer problem. This one we did a little bit of simplifying and then turned it into a 2-layer problem. Totally fine, doesn't matter. You could have done it from here by doing both sides divide by 4, which case we end up with the same as we had before. Nice thing about maths is there are often several ways of getting to the right answer, and provided they are all mathematically good, then really doesn't matter which one you do. If on any of these videos you reach the solution by a slightly different method from me, provided it's a valid reason and you end up with the right answer, it actually doesn't matter. That's totally fine. Okay, we're going to have a couple more practice of these in the next video, so I'll see you then. Bye for now, Batty fans.
Mwahaha! Mwahaha! Mwahaha!